my presentation, which is about the use of bacteriophages in the poultry industry. And then I will pause for a moment or two in case you have any questions. And then I've also attempted to make an overall summary of some of the take-home messages of this conference. So, is that on?
Is it green?
Yeah, it's green. Yeah. So I wanted, first of all, just to introduce the Phage Centre at Leicester. So we're basically, that's where all the work has been done, both the work that I'm presenting and the work that various others from Leicester presented. So we're now a team of 5 phage-focused academics. We have 6 excellent postdocs, 3 research assistants, and about 12 PhD students in total. So we have a really nice critical mass of phage research. So that's why we have presented for the last couple of days a few different projects. And essentially what we're trying to do with everything is establish really well curated, well understood phage banks. And there are some also often very interesting cross-fertilizations of projects between the two. But essentially, we're trying to move a little bit from beyond the lab to looking at the more translational pieces. So that's what I'm going to present to you today, the work in the poultry industry. We are also working, we have a project with the medical regulators, with the MHRA, and also with the VMD, the veterinary regulators. And so yeah, we have banks of all of those phages on the right side. So this is to summarize the work that we do at the Phage Centre. So you heard some work being presented yesterday by 2 PhD students, Riska and Theo, on urinary tract infection work. So we do quite a lot of work on bladders, some on guts. And we work at Leicester, there's a lot of lung physicians, mainly people working on COPD. So we've been doing a lot of work over the last few years, really trying to pull out phages for some of these more complex respiratory pathogens. And actually, Hannah just mentioned in her talk that the Moraxella bovis phages that she found for cow-eyes infect Moraxella cataralis, which the COPD people care about. It's a very annoying late colonizer in patients. And then we've just started a project looking at the skin bacteriophages with Peter and with Thomas, looking at necrotizing fasciitis. Oops. So in the animal space, we really need to have bacteriophage products for the sustainable production of food. So we know that as AMR gets more and more problematic, it's also it's giving the farmers are having a lot of pressure to not use antibiotics in the food sector. And actually, if you talk to the fish people, they say, well, all the land's been used up anyway, so we need to make aquaculture work. All the land's been used up, we fished all the fish. If we want to feed people, we need aquaculture, we need not to pump lots of antibiotics into the system. So there's a real motivation to use antibiotics there as well. But currently, one of our most favorite proteins as a race is chicken. So that's why we're focusing on that today. And then there can be a role in not just chucking away food. So we have the Slavs outlined the project with the langoustine. We have another project with pork, which came about because when I went around the biggest pork producer in the UK, we were actually working on our salmonella project, and they said, well, actually, can you help us with another thing about a large proportion of our meat just gets thrown in the bin because the consumers, they open it and it smells. It's fine. The bacteria are not harmful, but the consumers don't like it. So even though it says do not, this is normal, they throw it in the bin. So we've been chasing these phages for smells on rots. So yeah, we're a very popular place to visit in our institution. So the work that I'm going to be presenting today was mainly done by Anisha Thanki. So she's currently been involved in a side project, which I presented, a rather beautiful side project. He's 2 months old now. So therefore, that's why she's not here. I think she wanted to be. So I'll do my best to represent her work. So this is just showing to you why we need alternatives to antibiotics in the food chain. So if you look at the proportion of antimicrobial drugs to which more than 50% of bacteria are resistant, we can see animals, areas that produce a lot of meat, and where that production, that demand has increased rapidly, we can see we're seeing huge amounts of drug resistance. And depending on the country, up to 70% of all antibiotics produced are used in the food industry. So we've been working with salmonella and chickens and pigs. And I rather like this map. It's showing you where the non-typhoidal salmonella is. So the little shape is showing you where the most problematic animals salmonella that salmonella are associated with are. So we can see salmonella is associated with swine and poultry. These are actually the things that look like camels are actually cows. That are, anyway, we can see that salmonella is associated with different animals at a global level. And this is now just showing you the different types of strains that we find in pigs, chickens, and people. And just you can see typhimurium is really common. It's carried by pigs, it's carried by poultry, and then it's eaten by us. So the first thing we did several years ago was isolate a big bank of salmonella strains and salmonella phages. So we got hold of all of these most problematic strains from our UK collectors of such strains, which is the Animal and Plant and Health Protection Agency. And to summarize the steps in one slide that we went to initially. So first of all, we got hold of the phages and we showed that they were really, really broad host range. This particular family, one particular family of our salmonella phages could target all of those strains that I just showed you in the last slide. So we decided to work with them. And we then worked out how we would use them in feed. We worked out how to spray dry them. So this is, if you've seen spray dryers in the lab, this is what they look like. They're quite relatively small and easy instruments to work with. This is what they look like in reality when you want to scale up. So Anisha spent several days in a sort of this facility in Yorkshire where they normally spray dry milk and seaweed. So we had to persuade them to do quite different things to spray dry phages and make it work. But eventually we figured out how. And then having produced a ton of spray dried phages, I thought it'd be a shame if we didn't actually put them through some animals. So we put them through some pigs. And we showed, you can see these are the very distended guts of the pigs that didn't receive phages, that were just given salmonella compared to those that had salmonella. And we could see if we looked at the number of salmonella in the different sections of the gut, the phages made a very big impact in terms of knocking those numbers right down. So that gave us the confidence to go forward and look to see how they worked in poultry. Actually, I wanted to show you this when I talk about some of the practical things. This is quite funny. To actually produce phages at a level in agriculture, it's got to be really, really cheap because the farmers won't pay. I thought, sorry, there's some noises associated with this video. This is just showing what the sort of scale up parameters. So we spray dyed our phages, and then we had to, because the feed mill, the minimum amount of feed that they could make was a ton of feed. So we had to spray dry 250 liters of phages. And then the university were not very pleased to receive all of these spray dried bags of phages initially, and then the feed that came afterwards. That we can just see, it's quite fun actually seeing that project go from finding the phages and doing all your host range studies to doing, this not as familiar to you, Hans, probably not for all the others. So anyway, so she took the phages to the factory, and that's our first feed that contains phages all made. So we then gave it to poultry. And what was quite nice about doing poultry is, apart from the fact there was a really strong need to do this, we get a lot of data that's useful in other sectors as well, because the numbers are really quite big. So I'm going to show you just a graph or two from 3 different studies, but each study had 1,760 birds. So, you're lucky if you're fighting with your animal house, you can get maybe 20 mice to test something. And so the fishery people say these numbers are small and I should work with them, because then we'll do tens of thousands or hundreds of thousands of fish. But actually, we've got some really nice, robust data in an animal setting. So there's 112 birds in each different group that we treated. So we looked at giving phages in the feed continuously, and then in the water throughout continuously. So a chicken that you eat will only be between 35 and 42 days. So they just really grow them very quickly. And we also tried just giving the phages at the last minute in that the last week of the life of the chickens. So this is showing you what happens when you give them in the feed. So I mainly want you to compare red, which is just the salmonella, compared to 3 different dosages of bacteriophages. So 10 to the 5, 10 to the 6, and 10 to the 7 bacteria plaque forming units per day. That's what I'm showing you. And it was a little bit counterintuitive, this data. We can see that the lowest dose of the phages has completely eradicated salmonella from those poultry. So the other, whatever amount of phages we gave, we can see there's a knockdown in terms of the amount. But the most effective dose in this case was the lowest dose. So we published, that work's been published in just last year, and emerging microbes and infectious diseases. This work is just being written up, but this is now showing you what happens when you put the phages into the water. And here it was the lowest dose actually and the highest dose that have completely eradicated the salmonella from the poultry. The middle dose we still had a small amount, but considerably less than the controls. And actually in that particular study, the most effective group was the birds that we gave just for the last week of the life of the birds. We gave them the different phages, and regardless of dose, we didn't find a single, we had appeared to have successfully removed salmonella from the guts of those birds. So it's really nice data, I think, to show the power of putting phages, if you get the right phages, into a poultry system to really remove those pathogens. So I'm going to talk very briefly about another project where we've been doing a lot of work of late, Clostridium perfringens. So there's a different motivation really for doing perfringens, and that it's really harmful for the actual birds themselves. So the Salmonella typhimurium, the chickens carry it. They don't get that sick from it, if sick at all, but we obviously get. Someone was saying just at lunch, the Americans still have 1.2 million cases a year of Salmonella, of which 80% comes from chickens. So there's still a real incentive to get rid of it. Whereas the perfringens, that really harms the birds. So the farmers are they're more keen perhaps to have a product for perfringens. So we found lots of interesting phages that target a good variety of perfringens associated with poultry. We spent a long time looking at which would be the best combinations of phages. This is showing you all of the different phage cocktails that we tried. These are the different phages that are part of the cocktail. So we did a lot of work looking at the efficacy of phages individually and then combining them both, so using virulence assays, a little bit as Christian describes in his talk yesterday. And then you can see that these are the most effective cocktails in terms of their ability to infect 5 particular perfringen strains. I'm not going to, I won't be able to show you, yes, the data, the trial I think is really interesting because perfringens, unlike Salmonella, you don't just give one strain. So you give the chickens a protozoa, because that's generally how they get it. They have this horrible protozoa called an Emeria. And then they can elect different strains of perfringens. So in the model that we used, we had 5 different strains of perfringens and the protozoal infection. And actually the clean birds that came from the hatchery also had another form of perfringens already associated with them, because it's really hard to get them completely clean. And the phages appear to have, the data is not perfect, but you can see these are the amount of Clostridium perfringens that we see in the guts of the chickens compared in the animals that just had perfringens challenge compared to the standard treatment, which is the antiprotozoal agent. We can see that the phages have knocked it down at least a log. So there's a lot more work to do with the optimization of this, but we can see that again the phages are able to replicate and reduce the amount of Clostridium in those animals. But also when we looked at the lesion scoring, so these perfringens gives the birds really nasty lesions in the guts, that was considerably improved given the phage treatment. And the overall feed conversion ratio and other things that you look at were all improved by the phages. So quite a bit to do there. So going forward, one of the things we're doing is looking at increasing our production. So this has been talked about a little bit, the Leicester system. We're having quite a lot of fun using it. We've been able to really get very nice high yields and sustainable repeatable yields of bacteriophages using this system. Some phages, actually even Hannah's phages are really difficult to work with. She's been using the system and got several logs of improvement in terms of the amount of phages per mil. So clearly to get your products to the point where you can sell it, you need to have that reliable ability to be able to produce them. So that we're doing quite a bit of work on that piece at the moment. So yeah, I think hopefully I've sort of shown you the need to use phages in the food chain to reduce the passage of bacteria to us and to treat those animals. I think there's still a lot of well-designed trials that are needed to do, and the dosage is not so straightforward. But it may be that, as you can see from that poultry data, it could just be a section giving those phages at a certain period of the life of the animal can have a really big difference in terms of the amount of disease we're sending them out into the world with. And then, of course, to go forward to a product, there's a regulation piece. But I think the good thing is really that the data is really promising in terms of being able to reduce pathogens. And then also, I think it's so key to have that partnership between universities and the companies. So those trials were designed by 16 really good people that all they do is do feed additives trials. So they really knew how to hit 8 different branches to the study, so we could control for every piece along the way. I think, which is why we got such interesting data. So I'd like to thank Anisha and particularly Steve, another who's a postdoc in the lab, and Andy, who also helped with this trial work, and company AB Agri, who resourced the trials. Just like to mention before I finish, Phage Journal. So I am the editor-in-chief for Journal Phage. We launched this journal during lockdown. Little did we know that was about to happen, but it's going really well. It's supposed to be. We're hoping it's a very good place that people can publish their phage work. We got an impact factor initially of 2.7, and then last year it's just had an increase. So we're one of the few journals within the publishing house, or in general, where the impact factor is rising. So that's reflecting the quality of the papers that are being published, and it's a really, the papers are getting a lot of attention. A lot of people are really looking at them. They get really good download rates. At the moment, it's still free. I'm sure it's not going to be for very long. Thomas is also, he's a deputy editor, and Andy, who many of you know, is also, they have a section on introduce your phages. So there's a systematic way that we can compare our new. So you don't have to have a massive story about your phage. If you just got a new phage, you can do some basic characterization and introduce it to the world. So I recommend you publish it. And thanks to everybody in the center, and thank you for your attention.
I saw that hand up go out the corner of my eye. Martha, lovely talk, as always. Can I ask you 2 questions?
Sure.
Okay, the first one on the salmonella trial in the chickens. So you really had a lot, I'll try louder. You really had a big response toward the end as the chicken's getting older.
Yeah.
Is there a thing with maybe the way the intestinal flora is set up in the younger chickens? It's just not as effective? Phage therapy? Phage treatment?
Yeah, I don't know. It's almost just I don't know if it's just a numbers game. There was just some pens for some reason that's retained the salmonella. Some of the birds and some of the pens did have salmonella. So I don't know, because there are other studies. Hansjo, for example, I remember you showed some really beautiful data showing if you get the phages in really early, you can again stop that colonization. So I think yeah, I'm not entirely sure. I think that they are effective at different stages. I'm not sure why though, because it was just those few pens for some reason that we had that higher number.
Okay. And the other one was about the C. perfringens study. So you had 5 different strains of perfringens, and even the chickens that we got in already were colonized.
Yeah.
So first off, I'm wondering, are they part of the commensal organism? So you only have disease with an overgrowth, and your resolution of disease seemed to happen therapeutically just with a log fold. So even though the numbers don't drop much, the disease got a lot better.
Yeah, no, that's very true. It's a good point. Sorry. Yeah, I think, because I was initially quite disappointed when I saw those numbers, but actually when you look at the clinical improvement, that seemed to be quite significant in terms of really significant lesion scoring, and as I say, the other properties. So yeah, I mean, I think it clearly is. You can't. I don't think you'll be able to get rid of it, but perhaps if phages can just be used to control it, to stop the chickens actually showing disease. I mean, we're quite pleased that the healthiest animals, funnily enough, were the animals that we didn't challenge, that we just gave phages to, because that stopped, that nipped the amount of the low amount of challenge in the bud and stopped those animals getting sick. And I think as well, we gave them quite a lot. So probably it's probably not that high. It's probably, we probably gave them more in the challenge than they would be receiving. So again, you know, probably if we did studies where we're just using phages prophylactically and to stop the infection building up, I think that could be very useful.
We have one in the chat box as well.
Oh, good.
Online.
Can we see it here? So the question is, how were the dried phages added to the poultry feed? And did they survive the pelleting and extrusion process? Yes, one of the good things, actually, I didn't mention, one of the good things about those particular phages is that they're very heat stable. They're stable until 80 degrees. So that's one of the reasons why we selected them for the downstream purpose. So they were indeed, in that video I showed you, the phages were put into the mash that was pelleted. So we tried just putting them into the premix initially, but that denatured them. But they were fine in the feed. So.
Hello, I have a question. I hope I didn't miss the answer to this already. But I'm intrigued by the not more is better part in the salmonella treatment. Do you get a chance to look at the host afterwards to see whether it evolved resistance, or look at the dynamics of phage-host interplay during the time of treatment?
We have still got lots of samples to analyze for that. But the reason why we think it's probably the less that's more is probably working is that it's just the phages are targeting the bacteria, and then the immune system can work and clear things. So you haven't just got all of the phages just being removed, probably because when you have higher dosages, if everything's just removed straight away, then they're not sort of persisting through those kind of crenulated surface. So we think the phages are just sort of creeping along. But we have been looking at that both in this study and in other studies. We're trying to drill down more into those dynamics.
Thank you.
I had a bit of an ethereal question. Your slide at the beginning was really nice, showing all of the different areas that people are looking at phage therapy. And I was thinking about aquaculture and about agriculture and about chronic diseases where diversity just crashed, and we're getting these sort of single pathogens that have taken over. Since phages are everywhere, do you envisage a future where there might be some environments where we just enrich that environment for phage diversity so that phages can just sustainably restore that balance without us actually needing phage therapy at all?
I think so. I think that's a lovely question. I think that most of our talks over the last couple of days were very much focused on understanding that dynamic between one pathogen and one bacteriophage. But I think you're absolutely right in that if we can understand microbial diversity better and the roles of phages, and then we can basically use phages to restore microbial diversity, then I think there's going to be much more that will hopefully be the direction of travel in different cases. We can use phages, not just it's a different ideological approach, isn't it? In many ways, it's not just sort of scatter bomb everything. It's more like what's gone wrong, what's driven that lack of diversity, and how can we use phages to restore that? No, I think it's the way forward, I reckon.
Thank you. Okay, well, I'd like to thank all of our speakers, and I'll hand over to Martha for closing.
Yay.